In the year 133 AD, inside the imperial court of Luoyang, the air was completely still. Sitting in the center of the room was a massive bronze urn. It was encircled by 8 sculpted dragon heads, each facing outward and positioned directly above 8 waiting bronze toads. Without warning, the silence broke. A heavy bronze ball dropped from the mouth of the western-facing dragon, clanging into the open jaws of the toad below. The court officials were immediately suspicious. This device was designed to signal an earthquake. A few days later, a breathless messenger arrived from Gansu, a region 500 kilometers to the west. He reported that a massive earthquake had leveled buildings, and it had struck at the exact moment the ball dropped in Luoyang. The messenger's arrival validated the machine, confirming that the urn had successfully mapped a physical event occurring hundreds of kilometers away. To understand how it sensed the invisible, we have to look past the decorative bronze shell and examine the mechanics inside. The entire system is built on the principle of inertia, the physical law that a heavy object at rest will resist any change to its state of motion. Inside, a heavy central pendulum hangs perfectly still. When a distant earthquake strikes, seismic waves travel through the crust. Though too weak to feel, they move the ground underneath. The urn's outer shell shifts with the earth, but the pendulum stays locked in place. By harnessing this differential movement, Zhang Heng's device allowed a stationary mass to act as a fixed reference point against the moving world around it. At the pendulum's base, a narrow gap separates the mass from 8 surrounding lever trips. As the urn's outer wall shifts, it presses one directional lever against the stationary pendulum, tripping the mechanism. This sequence effectively funneled a broad, imperceptible earth ripple into a specific binary mechanical signal. That signal allowed the state to immediately dispatch aid to a specific cardinal direction. In regions like the rugged western deserts, imperial help could now begin its journey days before any survivors arrived at the palace. The original blueprints for this machine were eventually lost, but the incredible intellectual breakthrough of using an inertial mass to record the movement of the Earth remained. Modern seismographs on the right still rely on this exact logic, using a suspended mass and a rotating drum to translate ground motion into a visual record. In the year 132 AD, the inventor Zhang Heng didn't just build a mechanical alarm, he engineered a profound way for the human world to finally listen to the movements of the planet.